Welcome, everyone. My name is Jacek Wasilewski, and I would like to present to the joint work of myself and Neil Hurley on the intent-aware diversification using a constrained PLSA algorithm. Over the past few years, different frameworks have been proposed to increase diversity of recommendations, and the most commonly considered, I think, is the intra-list diversity. However, in this research, we focus on a different one, on the intent-aware framework. It is important to know that each of those frameworks, they promote different type of diversity, and the intent-aware diversity framework that we use assumes an existence of explicit aspects that items can be described by and user intents can be expressed by as well. The explicitness is really important because it makes it easier to understand the ranking process itself and to interpret the results. And those aspects that we're talking about, they are domain dependent, and in case of movies, for example, genres could be taken as aspects. The intuition behind the framework is that users have different aspects towards different, they have different preferences toward different aspects, and those should be reflected in the final recommendations. Also, the likelihood of items being selected are different, and they're different given the user intent. And finally, those aspects that items are described by shouldn't be overrepresented in the final recommendations. XQuad is a greedy ranker for the intent-aware framework that selects items according to the following formula, and that formula, it combines the baseline accuracy and diversity term using a controlling parameter lambda. This is the trade-off between accuracy and diversity. And the diversity term itself, it uses probabilities to express each of those previously defined rules. So 1, 2, and 3. And we do that over those explicit aspects. That's why we have the sum over A. We can also say that it tries to select an item on the assumption that all items previously selected are not relevant. And now, if we look at those probabilities that we use in the framework, so those probabilities, we can identify the concept of an aspect model introduced by Hoffman, where those probabilities are basically used to generate recommendations. And because of that, we think that any aspect model could be created and evaluated as a normal recommendation algorithm, and we believe that well-performing model would lead to better diversification, as they would be just simply more accurate. Two approaches have been used in the literature to estimate those probabilities. The first one, to which we refer as the explicit aspect counting model, uses explicit aspects. However, those probabilities are calculated ad hoc. As an alternative, we can use the probabilistic latent semantic analysis model proposed by Hoffman, where probabilities are inferred from the past data. However, latent aspects are used, so we don't know the meaning of those aspects. And we propose a middle ground approach where we make the PLSA to use explicit aspects, and we learn those probabilities from the past data. In our method, we constrain 3 variables used by the PLSA model by setting probabilities to 0 if we don't have any explicit evidence that, let's say, aspect is associated with an item. And as we said before, we believe that aspect models can be evaluated as recommendation algorithms. And here we can see the predictive performance of the model on well-known MovieLens 1 million dataset where 18 aspects are available. We can see that PLSA model performs the best on 18 aspects, then CPLSA and explicit aspect counter model. We can also see that comparable performance can be achieved on 8 to 10 latent aspects between the PLSA and the CPLSA. Now, if we look at the performance of the final re-rankings, we can see that on accuracy, the order of the models is the same as we've seen on the previous slide. Generally, CPLSA offers better performance or better accuracy than explicit aspect counting model and close to the PLSA. On the diversity metrics, such as alpha NDCG, which is a redundancy-aware version of NDCG, and sRecall, which just measures the number of unique aspects used in the recommendations. We can see that explicit aspect counting model performs the best. However, our further analysis showed that this might be due to model biases. And to sum up, in this research, we focus on the intent-aware framework and aspect models that are used by the framework. We propose a new aspect model that uses explicit aspects and is optimized for its predictive performance. We believe that the more accurate an aspect model is, the better diversification performance we can achieve in the end. And I would like to finish with a sneak peek from our more recent research, where basically we wanted to make those aspect models more accurate by introducing time. And here we can see, this is a graph on the diversity metrics. We can see the version with redundancy and without the redundancy. Here we are using the explicit aspect counting model. And as you can see, the difference between those two is very, very small. And it might suggest that the diversity, in this case, came from the aspect model itself, not from the intent-aware objective. And this is something that we are currently exploring. And that will be all. I'll be happy to answer a few questions.
We've got time for a couple questions. We got one right back over in this far aisle, midway back, and we'll look for perhaps one more.
Thank you for your interesting talk. I just wanted to ask you about your definition of intent. Since, for example, in the IR community, there are two definitions of intent that are generally used. So it's a word that sort of can cause some confusion. But how do you define intent?
So in information retrieval, I think the intent is the intent of the query, right? And here the intent is basically, intent is what the user would like to see right now. And here we don't have any evidence. So we assume that from the past we could, let's say, learn what the current user intent could be. So it's not like, I don't know.
So you might want to, for your future work, look at the other definition of intent, which is what the user is trying to accomplish at that moment. And that will give you sort of a richer idea of how to look at your aspects.
That's probably a good idea. Thank you.
Do we have one more? If not, I will take the last question. And I'm going to ask you, you sort of gave us a half of an answer when you said you had this better diversity performance, but you thought it was due to biases.
Yeah.
Can you say a little bit more about what you think is going on there? Because my first reaction is, well, gee, if I can get better diversity, that's the kind of bias I want.
So other thing that we found out is that those diversity measures that let's say the alpha and DCG, I think that the measure itself, the metric itself, is, let's say, biased toward that model. Yeah, so, I mean.
So it's not a neutral diversity metric, and so
yeah, that's what I think right now.
Fair enough. Well, thank you again, and
thank
I
you.
want to thank all of our speakers, all of you for being here, and